All right, guys, so in our video here, we are going to be looking at displacement and distance traveled, utilizing what we know about integrals to go from either acceleration to velocity and velocity to position. So utilizing our integrals to go ahead and find the following. And so as you can see here on the screen, we can find displacement or the position function by taking the integral of both the x and the y components of the velocity vector. Now, what about distance though? Well, think about it for a sec. If our speed is the magnitude of velocity, we need to find the total distance. Well, the distance is just the magnitude of position. So what we're really looking to find is the integral, or that step above the speed magnitude. And so we need to almost integrate speed. So think about that for a sec. Distance travel is almost the integration of speed. And I want to go ahead and take a look at this concept here. And if you wanted to go ahead and pause that video as you're kind of writing this on down, please feel free. So let's take a look. Our first example, all right, finding displacement and distance. So it says we have a particle in the plane with velocity vector v of t equals, as we see there, at t equals 0, the particle is specifically at the point 1, 5. Find the position at particle, or of the particle at t equals 4. Okay, well, displacement. So let's think here for a sec. Find the actual position of it when it is at 4. So for part A, I am now been given the velocity, but I don't want velocity, I want position. I want to figure out what happened from the starting point to t equals 4. So I'm not really looking at necessarily velocity, I'm looking at wanting to find position. And so I want to find r of t, and in this case r of t can be found by taking the integral of velocity. But from what to what? Well, think about it. The position at t equals 4. You're asking yourself, what happened from 0, the start, to t equaling 4? After t equaling 4, I don't know, seconds or whatever, minutes, whatever it is, right? What happened from 0 to 4, and where did you end up at t equals 4? So I want to find out what happened from 0 to 4. Of my integral t minus 3 pi cosine pi of t dt, comma, from the sine aspect of it, we're still integrating from 0 to 4 to t minus pi sine of pi t, all still dt. All right, well, now, remember, the goal of this section is vectors, right? It really is vectors. And yes, understanding the concepts between vectors, integrals, derivatives, and so on and so forth. However, all right, there are times where I want us to really focus on the task at hand, and that is to look at vectors. And so this is going to be an opportunity to utilize our calculators to evaluate definite integrals, all right? Definite integrals. And so we can actually do this on our 84 plus. So let's take a look here. So as you see on the screen, I've gone ahead and solved these two using our TI 84 pluses. We do that by going to math, going down to 9 to our integral, all right, function that we see right here. Click enter, and that is what we see here. Now we'll substitute it on in. You have to be careful. You have to make sure that you put in your dx. I get we're in terms of t, but everything is x in terms of our function on our calculator. If you do not fill in the x for the dx, you are going to have an error result happen. So make sure that you're kind of practicing with this as well too. And so by evaluating these two, I get the x component 8 and the y component 16. But wait! I'm not quite done, because the particle started at t equals 0 at the point 1, 5. So it's just not 8, 16, because that's where it was when t equals 4. I want to know where it started out with. So 8, 16 gives us the movement from the starting point. Well, the starting point was at 1, 5, not at 0, 0. So I have to add the vector 1, 5 into the mix. And so we can see here that 8 plus 1 is going to be 9. So it'll be at the point 9, 21. All right? And again, I can put it in parentheses because this is a position function. So what about part B where it says what's the total distance? Well, remember what we said in the above slide, that distance traveled is the integral of the magnitude for velocity. All right? So the magnitude for velocity, so really it's the integral of speed that we're trying to find. So the integral of the velocity function. All right, well, let's take a look here. I want to go ahead and find the integral. Once again, we're going from 0 to 4 of our displacement. Well, this is our, or not displacement, but our distance formula. So I'm looking at the change in velocity, right? The change in velocity. Well, the velocity in this case will end up giving me my t minus 3 pi cosine pi t all squared plus the sine aspect of it, which is the y component, 2t minus pi sine pi t all quantity squared. Now, I admit, that is an ugly, ugly, ugly integral to go ahead and solve for. And so let's kind of focus on the vectors at hand and not have to take up so much time utilizing it. And let's kind of have some fun with our calculators as well too. So let's go back up to our TI-84 plus. So once again, you're going to go to math. You're going to hit 9, and that's going to give you your function that looks a little something like this. And so utilizing our integral function here, I've gone ahead and substituted in our function, all right? And again, we're from 0 to 4, and just make sure that your parentheses are in line when doing so. And so you end up getting 33.53 for the value. And so that actually is the total distance traveled of our position function. So in the end, 33.533, give or take a few, from 0 to 4. All right, guys, hope you enjoyed the video, kind of showing the relationship between velocity, acceleration, speed, and all the above, and how it's relation to integrals to find displacement. On to the next one.